Hi, today we are going to see design of FIR filter using window method, and especially we are going to design the ideal filter, and this is vanilla. So in spite of this Fourier series method, why we are going for the window method? So what is the need for this is, we are converting the infinite series into a finite series in FIR filter. In Fourier series method, in step 3, we are just making it as a finite series as minus n minus 1 by 2 to n minus 1 by 2. So this abrupt truncation of the infinite series to finite in Fourier series method leads to an oscillation both in pass band as well as in the stop band. So this oscillation are due to the slow convergence of frequency Fourier series, and particularly near the point of the discontinuity. So this is called as a Gibbs phenomena, and to avoid this one, we'll multiply a suitable window technique so that the undesirable oscillations can be getting reduced. The desirable characteristics of the side windows, these are the desirable characteristics of the windows here. So design procedure, so here you have 5-step procedure. So step 1 is to choose the desired frequency response of the filter. So HD of e power j omega. So the next step 2 is to take the inverse Fourier transform of HD of e power j omega to obtain the desired frequency, desired impulse response. So HD of n equal to 1 by 2 pi integral minus pi to plus pi HD of e power j omega into e power j omega n d omega. Step 3 is, this step 1 and step 2 is similar to the Fourier series method. Step 3 is choose the desired window sequence and multiply with the infinite duration HD of n to the obtain your finite duration. So for ideal system, the H of n will be obtained by HD of n into your W of n. So for the limits minus of n minus 1 by 2 to plus n minus 1 by 2. Then step 4 is to take the Z transform. So for a causal system, H of Z is equal to Z power minus of n minus 1 by 2 to H of 0 into summation n equal to minus 1 by minus of n minus 1 by 2 H of n Z power minus n plus H of Z power plus n. And step 5 is to draw the suitable structure for realization of FIR filter. So here the way to identify the types of filter are, so check the number of cutoff frequency given here, whether it is 1 or 2. If the number of frequencies given is 1, then it belongs to either low pass filter or high pass filter. So here the time period minus pi to plus pi will be sectioned into 2 as minus pi to 0 and 0 to pi. So here the cutoff frequency omega c will be placed in between the 0 to pi as omega c and 0 to minus pi as minus omega c. If your value if it has the value, if your desired frequency response has the value of the range minus omega c to plus omega c, then it belongs to low pass filter. If it has the range, if it has the value for the range minus pi to minus omega c and omega c to pi, then it is called as a high pass filter. So if it has 2 cutoff frequency, then it belongs to either band pass or band stop filter. So here say 0 to pi will be having omega c1 to omega c2, and 0 to minus pi have minus omega c1 to minus omega c2. If you have the value for the range minus omega c2 to minus omega c1 and omega c1 to omega c2, it belongs to band pass filter. And if it has the value for the range minus pi to minus omega c2, minus omega c1 to plus omega c1 and omega c2 to pi, then it is called as a band stop filter. So this is the table that you have to copy for the desired frequency and impulse response of the ideal filter. When a filter is said to be a ideal filter, if it is going to have the value as 1 for the specific range, right? So for low pass filter, minus omega c to omega c. For high pass filter, it is minus pi to minus omega c and omega c to pi. This modulus of omega means plus or minus omega, and its corresponding HD of n has been given. This table is similar to that of the Fourier series method. and window section for function for the ideal filter. So this is the three formula that we are going to use: rectangular, Hamming and Hanning. So rectangular window, the value is 1 for minus of n minus 1 by 2 to n minus 1 by 2, and here 0.54 plus 0.46 cos 2 pi n by n minus 1 for the range minus of n minus 1 by 2 to n minus 1 by 2, and for Hanning window, this is the thing. So this window function we can see during the linear filter, design of the FIR filter, linear FIR filter. So we will solve one problem here. Compute the first 11 coefficients of FIR filter using a Hamming window with the frequency response. So they have given the frequency response, and from this frequency response we can categorize. They didn't give anything about the which type of filter. So by seeing this function we can identify which type of filter. They have two different frequencies, pi by 2 and 3 pi by 2. So it belongs to either a band pass filter or band stop filter. But here you have the modulus, so the meaning here is it belongs to minus 3 pi by 4 to minus pi by 2 and pi by 2 to 3 pi by 4. So minus omega C2 to minus omega C1 and omega C1 to omega C2. So it belongs to band pass filter. So first the filter is band pass filter that we have identified. The category is ideal because the value of that particular range is 1. And window technique that you have, you are asked to do is Hamming window, and your omega C1 is pi by 2, omega C2 is 3 pi by 4, and your n value is 11. So this is pi by 2. So n value is 11. So first step is to choose the desired frequency response. So since we find the filter, in spite of getting this one, we can have a generalized one, so that at the end we can substitute the values alone. So for band pass filter, 1, the value is 1 from minus omega C2 to minus omega C1, and 1 omega C1 to omega C2. Step 2 is to obtain the desired impulse response. So the formula is 1 by 2 pi integration minus omega C2 plus omega C hd of omega C1 hd of e power j omega into d omega. So here this limits is minus omega C1 to minus omega C2 to minus omega C1 and omega C1 to omega C2. The value of hd of e power j omega is 1. So now integration of e power j omega n is nothing but e j omega n divided by jn. So and here also e power j omega n is e power j omega n divided by jn. So upper limit minus lower limit. So e power minus j omega c1 n minus e power j omega c2 n plus this one, I take this 1 divided by 2 pi jn commonly out. So omega c2 minus omega c1. So now I can rearrange this one as bring all your omega c2 on one side and omega c1 another side. So here I have minus, here I have plus, so I will bring this one to this side. So omega e power j omega c2n minus e power j omega c1n, and I am just breaking this to this side. So always your first will be your positive value. So I will take your minus out. So e power j omega c1 minus, so this plus becomes minus e power minus j omega c1. So this is going to be, just bring your 2j inside. So if I bring 2j inside, what happens is e power j omega c2n minus e power minus j omega c2n becomes sin omega c2n, and this becomes sin omega c1n divided by pi into n. So this is for n is not equal to 0. Now for n is equal to 0, it becomes 0 by 0 in determinant case. So applying your L hospital rule, sin a theta pi theta is equal to a. So here this is going to be omega c2 minus omega c1 divided by pi. So this is for n equal to 0. So now step 3. So what's the step 3? Find the desired impulse response. So hd of n is equal to sin omega c2 minus c2n minus omega c1n for n is not equal to 0, and omega c2 minus omega c1 divided by pi for n equal to 0. So your omega c1 is pi by 2 and omega c2 is 3 pi by 4. So I can replace this omega c1 and omega c2 value here, and this is the hd of n. Now step 3. Step 3. Choose the desired window sequence and multiply with infinite duration hd of n to obtain the finite duration. So for ideal system, h of n is equal to hd of n into w of n. For the time period is going to be n equal to minus of n minus 1 by 2 to plus n minus 1 by 2. Here n is equal to 11, so minus 5 to plus 5. So here the hd of n they have given is for n is not equal to 0, this is sine 3 pi by 4 n minus sine pi by 2 n divided by pi n, and the window technique that they have used in the problem is Hamming window. So let us see how to solve this one, right? So make sure the calculator is in the radians mode here, right? So here type it the value as such. So open bracket sine, again on open bracket, so 3 into pi into n, so shift alpha divided by 4 close bracket minus sine open bracket pi into alpha a divided by 2 close bracket, again one close bracket divided by open bracket shift pi into alpha a close bracket. So make sure that the value is going to be correct. So here after substituting, after entering the values here, just changing your n value, you are going to get all other values here. So make it sure that you have entered the correct formula here, right? So the formula, as per formula, is going to be sine 3 pi n divided by 4 minus sine pi an divided by 2 close bracket divided by pi into n. So in spite of n, I have made use of your a. Now you have to press the button calculate. So now you have to find the value of minus 5 to plus 5. So minus 5 equal to, so the value is minus 0.1087. So next value, calculate minus 4 equal to, so the value is 0 here. Then calculate minus 3 equal to, the value is 0.1811. Then calculate minus 2 equal to, the value is going to be minus 0.1591. So next is calculate for minus 1, and then the value is going to be minus 0.0932. So here for n equal to 0, we have another formula. The value is going to be 1 by 4. Right? Again, find the value of 1. So calculate 1, the value, then calculate 2, the value, for calculate 3, and the value, calculate for 4, and calculate for 5. So this is the answer. So we got it in the way here. So similarly, we have to get we got hd of n. Now we have to find the w of n. So w of n, the window sequence that we have chosen is Hamming window here. So formula is 0.054 plus 0.46 cos 2 pi n divided by n minus n, and then the value is minus 5 to plus 5. So 0.54 plus 0.46 into cos open bracket. So here 2 into shift pi into your n is alpha a divided by n minus 1. 11 minus 1 is going to be 10. So calculate. So when the value, you have to find it for minus 5 to plus 5. So minus 5 is going to be 0.08. Calculate for minus 4 equal to 0.1679. Calculate for minus 3 equal to, value is 0.3979. Calculate for minus 2, it's going to be 0.6821, and calculate for minus 1. The value is 0.9121, and for value of 0, for value of 0 is going to be calculate for 0 the value is 1, and again find it for 1 2 3. Here calculate 1, then calculate 2, calculate 3, calculate 4 and calculate 5. So we got the window sequence value here. So we got HD of n as well as we got your W of n. So once we type the formula correctly in the calculator and you just replace this small n by alpha a. So by changing this n value alone, we will be able to get the entire sequences here. Now the step 4 is to find the step 3. Before step 4 we have to find your h of n. So multiply your hd of n with your w of n, the values that we got. So hd of 5 into w of 5, hd of 4 into w of 4. So for each and every value you are going to multiply the corresponding desired value with your window sequence. So we will get the values here. Step 4, take z transform of h of n to get h of z is equal to z power minus of n minus 1 by 2 into h of 0 plus summation n equal to 1 to n minus 1 by 2 h of n z power minus n plus z power n. So here z power minus 5 into h of 0 plus replace, just expand the summation from substituting n equal to 1 to 5. So I got this one. Now multiply this z power minus 5 throughout. So substitute your values of h of 0, 1, 2, 3 and multiply your z power minus 5 throughout. So if I multiply this one, so here 0.007 into z power minus 5, it becomes 1 plus z power minus 10. So I just rearrange this one. You just multiply with this and then rearrange. I'll get your h of z this way. Now step 5 was to draw the structure. So since it's having your n equal to 11, so n minus 1 will be 10. So upper part 5, lower part 5. So this is going to be z power minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, 7, 8, 9 and 10. So as per the structures h of z, so h of z is equal to minus 0.00871 plus z power minus 2. So here this is going to be 1, this is going to be z power minus 2. So minus 0.0087 into z into 1 plus z power minus 2, 0 into z inverse plus z power minus 9 minus 0.0721 z power minus 2 plus z power minus 7 and minus 0.1085 into z power minus 3 into z power minus 7. And then this is going to be z power minus 4 into z power minus 4 plus z power minus 6. So into your coefficient and then plus 0.25 into z power minus 5. Thank you guys. Subscribe my channel for automatic updates. Have a nice day.